easy coding problem. Okay. Minimum operations to make array values equal to k. You get an array nums and integer k. Excellent. Length of nums is going to be n. Integer h is valid if all values in the array that are strictly greater than h are identical. Integer h is valid if all values in the array that are strictly greater than h are identical. For example, if the nums array is 10a, 10a, a valid integer is h equals 9 because all numbers that are bigger than 9 are equal to 10. And 5 is not valid because all numbers bigger than 5 are not equal. There's 10 and 8s. You're allowed to perform the following operations on nums. Select an integer h that is valid for the current values in nums. For each index where nums at I is greater than h, set nums of I equal to h. So for every number that's bigger than h, make it h. Return the minimum number of operations required to make every element nums equal to k. If it's impossible, make all elements equal to k, return -1. All elements equal to k. Interesting. So here 2. So you need to set it to 4 first, so h is 4, so that all the 5's become 4. And then you set h is 2, and everything becomes 2. Why would it never be possible? It wouldn't be possible if k was bigger than the smallest element, because you're lowering it down to h, and you can't lower it to something where the smallest number is already smaller than that low. Okay. So for instance, if k is 10, there's no operation here that would lower everything to 10. Here 2, yeah, this is not possible because the lowest value here is bigger than 2, or smaller than 2, here it's just 1, oh no, it's 4 times, so 9 becomes 4, 9 becomes 7, then 7's become 5, and 5's become 3's, and 3's become 1. Alright, it's pretty straightforward, I think. It's just the number of distinct elements bigger than number of distinct elements that are bigger than k. Number of distinct elements bigger than k. And well, let's do the not possible. Not possible if smallest number in nums is smaller than k, because you're reducing everything down to you're reducing everything down each time. But if the smallest number is already below that, then it's just not possible. So if the min of nums is smaller than k, turn -1. Alright. And then otherwise, it's just the number of distinct elements. Yeah, it's just the number of distinct elements. So distinct count is equal to the set, the length. Let's just consider the distinct values. Distincts is the set composed from nums. So this just reduces down to what are the unique values, and then and it's basically going to be everything in that set that's bigger than k. No, everything has to be bigger than k, bigger than or equal to k, so it's exactly equal to that set. It's equal to the length of that set, -1 if k is already in there. So for instance, because k is in here, the number of distinct elements here is 2, 5, 4, 5. So there's 3 distinct elements, but because 2 is one of those distinct elements, you don't really need to worry about that one, so it's just 2 times, but here there's 4 distinct elements, and because 1 is not one of the distinct elements, then it's all 4 times and reduce. So if k is in the is listed within the distincts, then just return the length or the size of the number of distinct elements minus 1. Else return exactly the length of the distincts. All right, and I think I can maybe make this slightly faster by saying that, or not faster, but I can make this into return length. Let's say if k in distincts, then whatever, return length of distincts if k not in, if k not in distincts, else length of distincts minus 1. I think that's correct, not syntax. I'm not quite sure. Alright, for some reason that was slightly slower. I like the first time around. Let's try one more random sample. Alright, I think that's good. Is there a faster way of doing this? You get the length of the nums. I guess you don't really need to get the length of nums. And then you do need you do need to find the min of nums. I guess you could find the min of the distincts. If min of distincts is smaller than k, return -1. I'm not sure if this is any faster. How do you comment? Okay. Sometimes I blank out on the hotkeys. I don't know if this is any faster. Alright, slightly faster. I guess going through the set of values rather than all the values to find the minimum is something. Alright, I am good with this. Okay, summary. Alright, this is just simplify the problem as based on how many distinct values are above k, or greater than or equal to k. If there are any below, not possible. If k is within those values, one less operation is needed, and use convert array to set using set on the nums. For quick analysis. Quick analysis, yeah. Yeah, it's just sometimes you gotta just know how to change data structures in the language that you're dealing with. And then time complexity here is going to be O of n. in order to convert to set and also to find lowest value. And then space complexity is also O of V, where V is the number of unique values in the array, which in the worst case is O of n, because as V is less than or equal to n. Is there anything else? No,